So we have our homework quiz for chapter 3. Again, we'll take a look at this, get a preview of the types of questions we'll be asking you to work through in the homework and get some familiarity with. Okay. So for the first question, determine the mean, median, and mode of the following data set. So what we're going to do is we're going to enter this data into our calculators, and what we're going to use in statistics, some we've been using so far just the regular calculator. Let me introduce you to our other 4 best friends. So there's this in the menu, the statistics we'll be using at the beginning here. Then in chapter, I think, 4 or 5, a little bit later down the road, we'll use distributions, and then we're going to look at inferences, and finally we come back to regression. So it's these 4 little these corners here. So we'll start with the statistics calculator. In this one, we just get to enter in the data. So I'm going to do 54.1, enter, and that's a frequency of 1. You could put frequencies like you've got this 95.9 happening 3 times. You want to save yourself a little bit. You could enter it 3 times, but you could also do it this way. Just make sure that's happening 3 times. So we've entered it that way, and the software takes care of everything else. 70.4, and I just do that, and it does it 1 time. The rest are all 1 times. So 77.4 and 64.4, 84.8, 65.6, and 79.6. What you want to do is make sure you got it all entered in correctly. 54.1, 95.9 occurs 3 times, 70.4, 77.4, 64, 84, 65. Because if you have an error in any of these, you will have an error in your answer, and vice versa. So if you get one of these wrong, it's most likely going to be that you've entered one of these wrong. You've transposed a number or something. I do that quite a bit myself with transposing things. So double check them. We'll go over to stats. And this gives us all the information we need. It starts off with, we'll talk about all these eventually, but here's the median number is 78.5. So the median we can enter here, 78.5. Find it for us. We arrow down, keep going, we get the mean is 78.4. 78.4. And then the mode, it will give us that. There it is, 95.9. The thing that happened 3 times, I mean, that should have gotten us, but again, the software will handle it all. It organizes it for us and takes care of it. Okay, so know how to work with that feature of putting in the data and doing 1 variable statistics. Table below gives the number of hours spent watching TV last week by a sample of 24 children. They want the range and the standard deviation. Now, the range is not so hard. You could probably do it without entering all these if you could find the largest and the smallest and then just subtract them. However, standard deviation isn't as easy a calculation as that. So we're going to enter all this data in and have the calculations done from within the software. What we're going to focus on is using technology to get us these answers, and we want to focus on what the answers mean. Okay, so for here, I'm going to clear out this list. If I come up to value and I hit clear, I confirm. Notice it cleared out the list. Notice I can't click up here. I still have to use all these keys. Okay, So now I just go through and enter this list, 89. I'm going to go horizontally across 35, 73, 31, 51, and 85. Back 71, 46. It's just a little tedious, maybe a little boring, but as boring as having to calculate the standard deviation by hand. And if you calculated it by hand with this amount of numbers, there's a high likelihood, at least if you're like me, of making some errors. 36, I guess I could have said there was 2 of those, but regardless, it all gets entered. Okay. We've got it all entered in. I should have been keeping track. Should have, there's 4, 2, 3, 4, 5, 6, 24 total numbers entered in. Since the software in here, once I put it in, it'll tell me whether I'm right or wrong. I'm just going to go up and over to stats. Now, notice we are dealing with a sample. Here's an important thing. This will calculate everything for us, but it's going to give us 2 standard deviations. First of all, I think, where's the range? Is the range up here? Oh, there it is. Range is given us, it's the largest minus the smallest. So I think I see 99 as the largest and 12 as the smallest. So if you subtract those 2, yeah, you get 87. So, that's a good way to check it. Standard deviations, much more complicated. And what you're going to see, there are 2 standard deviations. So there's this first standard deviation with the sigma. That is for the population. And then down here, there's a sample standard deviation. And notice those numbers are different. 23.45 for the population, 23.97 for the sample. The sample, because it's coming from a sample, we have to use this one. Remember, the formula is n minus 1. So it's divided by a smaller number, which actually makes your sample larger. Sorry, not sample larger, your standard deviation slightly larger for the sample than it is for the population. But just make sure you choose the correct number. If you come over here, you just highlight it, 23.97. Nearest hundredth is 2 decimal places. The 7 stays a 7 because next to it is a 1. So 23.97. Okay. Now, we'll just check it. Yeah, it worked out. Okay. Enter it in. Calculator will do these. I see no great feat in being able to calculate the standard deviation by hand. What I want you focusing on is concepts, much like this. Understanding. Outliers have very little or no effect on which of the following. Okay, outliers, remember, are pieces of data that are extreme, either very large or very small. They are going to affect things like the mean, because that's you're adding a very large number or very small number to some others. So the mean, it will have an effect on. Standard deviation, it will, because as you put a piece out there, standard deviation is how spread out the data. So it will also affect standard deviation. It will also affect the range, because think about it, if you move a piece of data out, the range becomes bigger. The 2 that it won't affect very much at all, well, one that it just won't affect, is the mode, because that's the one that occurs the most frequently. So you could have an outlier way out in your data, a really big piece of data, and you got 97, 97, 97, 97, a bunch of 97s. That's going to be your mode, regardless of what an outlier does. Also, the median, because you're going to line your data up in order, and so there's a piece of way out here, but it's so notice 1, 2, 3, 4, 5, 6, 7 pieces of data. 1, 2, 3, 4. This is going to be your median, the one in the middle. 3 here and 3 here. It doesn't matter whether this one was here or over there. Your median's not going to change. Okay, so median and mode are not affected by outliers. All these others are affected by the outliers. Let's see if I got it right. Sometimes I go through these and exactly, because the range is a spread, so standard deviation, so the outliers create greater spread. And they do affect the mean more than any of the others. Complete the following statements. The first quartile corresponds to the blank percentile. The median corresponds to what percentile? So a percentile is 100 percent. So we go from 0 to 100%. Quartiles divide the same area into 4 pieces. So we still have here and here. We cut it in half, and then we cut it in half, each of the halves in half. So this is going to be 50%, right? So if we were up here, it would be 50%. That would be the median or the second quartile. First quartile, that's 25%, right? That's what a quarter is, 25 cents. And Q3 is halfway between the median and the biggest number. That's going to be the 75th percentile. Okay. So quartiles are 25, 50, 75 in terms of percentiles. Let's go ahead. Again, you might have some different ones in here. I imagine they're probably going to be the same for this specific question because quartiles to percentiles. Okay. Wow, here's a sample data set. It's a lot of data. Find the first quartile for the set, third quartile, find an interquartile range for this data set. Well, it's again a tedious thing. The calculator will give us all the answers we need. We could put these in order and then find halfway through and find all the quartiles. That's also tedious and very easy to make an error on. So I'm going to suggest we just enter the list here. So I'm going to clear this out and put this in. Now again, you can use any calculator you want. You're going to see there's will be super benefits for using the NumWorks as we go forward. It has a lot of really good features for statistics that are both visual and numerical. It gives you all the things you need for the formulas so you can understand what's going on. It's the newest fully redesigned calculator that I've seen. TI-84 is a good calculator, but they spent so much time being backward compatible that they're still 30 to 40 years behind the times. So anyway, let's go ahead and see if I can get all of this entered in 406.1 correctly. And again, I like to go horizontally and then work down. And again, if you want, you could just fast forward past this. 353.8, 357.3, 3.9, 378.7, 466.1, 459.8. Wait, I'm getting in the wrong place here. See, this is the problem. So I did 466.1. then it should be 407. So I just got to keep on track here with my fingers. And 405.1, 353.8, 74.7, 354.1, 466.2, 459.8, 264.9, 356.8, 470.8. Actually, I think I can pause this. Well, I'm not sure. Anyway, I'm going to keep going. I don't want to. You can fast forward this if you'd like. 406.1. Maybe just do it. I tend to talk while I'm doing math. Oops. 92.3. So if it, you can turn your volume down if you don't want to hear me talking, but it's just something I do. 401 helps me think. I think because it helps me from getting too bored. Just entering numbers. 489.8. Also, I'm dyslexic, so 354. It's something I do to help keep me focused as well, because my brain starts wandering off. Okay, 363.4, 354.9, 364.8, 292.4, 368.8, 408.4. I don't know, was it really necessary to have this much data? If I was doing this problem, I'd cut it in half, but anyway, it's what we've got, so we got to do it. 364.8, 471.2. If you miss a decimal or anything, that's the thing with this. Make sure you get it all entered in there correctly. I'm sure if I've made a mistake, you've seen it. I've maybe blown over it, but we'll see. See, if I stop talking, I start making mistakes. 384.9, 460.5, 340.8. So the math is kind of a meditative thing at times. Again, it's tedious, but numbers, I like numbers. They you can always count on them, right? They don't change their moods from day to day. They're always the same. 406 plus 1. 1 plus 1 is always 2. 2 times 2 is always 4. 369.3. I guess what would be nice is if they kept the total in here, but they don't. So I'm just going to say I'm kind of tired. I entered everything I could. Let's come to the top. We're going to go over to stats. If I've got it all entered in well, I'll get it. So the first quartile, I want the first quartile, which is Q1, is given to me as 353.8. Over here, 353.8. Now, if that's not correct, it's because I may have entered something wrong. But other than that, that's it. The third quartile, so come down, here's Q3. The third quartile is wish it was a little bit bigger. It's hard to see this. Let's see, I think if I go over here, does it help? 395 or 385? Maximum 389, so it must be 485.1. 485.1. And then the interquartile range, that's what I like about this calculator. It actually has it. A lot of calculators, they don't do this part. So interquartile range is this. What it is that's Q3 minus Q1. So you could do it over here from the values you've got, but it's 52.3. 52.3. It gives it to us. Let's check our answer. I hope I'm right, because if not, it means I entered something wrong. I got this last one wrong. And maybe it was just the way I read it. 486.1. Oh, I just read it wrong. Looks like a 6 now. Or is that a 5? It's 486. But the nice part is we can correct these. 486.1. I think it's so small. I think I just read it wrong. But you get a second try. It still didn't like it. And then after that second try, well, I can click 406. Oh, that's a 0. That's not an 8. But mine, it was okay. I just didn't see it very clearly. I'm not going to go ahead and redo all of them because that's what it is. But you get the idea of how to do this one. Okay. And then I would just, one of the things you can do, one of the things I should have done, let's do this. You can make this bigger. This is the one I got downloaded. And if you go this route, it makes it bigger. That's what I should have done the first time. And then you can actually see them. My eyes are not getting any better. 406.1. So I had the right number. It was right there. I just couldn't read it. I do have a physical version of this calculator, or if you use it on your cell phone, you'll probably get a better view. And if you use it this way, it's nice. Thing is if I do this, then it covers up the question. And so you can make it bigger. You see this, and then, but I've seen a lot of students that I work with in the in-person version of the class use their calculators this way, which is great. But it shows up on the screen a little bit better if I go like this. But maybe I could, Okay, we just got one more anyway. Okay, remember you can always fast forward. The 5-number summary of a data set was found to be this. An observation is considered an outlier if it is below what number? Okay. This is a 5-number summary. Observation is considered outlier is above what number? The rule of thumb that we work with is we take this interquartile range. And if it's more than, should have looked it up before. See, all these things you think you remember. I think if it's more than 1.5 times the interquartile range, then that would be, and then you subtract that from the Q1 and you add it to Q3, and that would give you your outliers. Let's see, I was thinking this one kind of would do it for us. But let's see. Okay, so interquartile range. This is Q1. This is Q3. We take Q3, 68, subtract Q1, 53, and we multiply that times 1.5. Or is it 2.5? I thought it was 1.5. We'll see. We'll back up if we need to. So this is going to be 10 plus 5, so that's 15. 1.5. Over here, back to the regular calculator, 15 times 1.5 is going to be 22.5. So outlier, if it is below, so then what we do is we take the Q1, 53, and we subtract off 22.5. 53 minus 22.5 gives us 30.5. So that anything below that number would be an outlier. And then we take Q3, 68, you add the 22.5, that will give you an outlier on the other end. 8 and 2 is 0, carry the 1, 6, 7, 8, 9. So 90.5, that would be the high end. Anything above 90.5 considered an outlier. Let's just do the check this way so I don't mess all this stuff up. Hey, I got that one right, and I got that one right. So the thing I was worrying about was there's a bunch of little different numbers that you got to remember, and this is one of them, the 1.5. We deal with the mean standard deviations and stuff. I think it's 2 standard deviations. So anyway, these are types of things that I encourage you to have on your little note card. Outliers with when we're doing a 5-number summary, interquartile range times 1.5. Have that somewhere. You just need to be able to apply it. Have it someplace where you can reference it. Because these are not things that we necessarily do every day, right? And so sometimes we forget them, but have those there. Okay, this is the last question. The box plot below shows salaries for construction workers and teachers. So construction's on top, teachers are on the bottom. The question, Jenny makes the median salary for a construction worker. Construction worker, median salary on a box plot is going to be this line here. So this is Jenny. What we can see is she makes $40,000. Marcos makes the median salary for a teacher. So here's the teachers. The median is this middle one right here. Here's Marcos. Who makes more money? Well, Marcos makes 30. I mean, you could visually see right here. Certainly, it's got to be Jenny. She's making more. By how much? Well, Marcos makes 30. Jenny makes 40. 30. If you subtract those two, you get 10,000. So Jenny makes $10,000 a year more. And again, we can just click here and here. We get the right answers, but we can also check our answers. And at the very end, you can always submit and end, and it will check everything. Check answers as you go, submit and end. And then once you've done that, you've got everything recorded. Hopefully, you've been checking as you go. Not much I can do here, but notice it's a few points for that one. And all that was about was I should have taken the time to make sure I could read the numbers that were in the calculator. Okay, but you'll see similar. Okay, you can't change them after you submit. Well, that's too bad. Okay, so it's there, and what that does is it would put the score into the grade book as well. So then what you want to do after this is 94. That's pretty good. Work the homework, and then after chapter 3, we have an exam after this. So then go back and review chapters 1, 2, and 3. There's some practice tests to work through, and yeah, you'll be good. You'll be ready for that first exam. All right. Thank you very much.